In this lesson, we will continue to study the surface drainage facilities of subgrades. In addition to the side ditches and interception channels we have already learned about in the last lesson, drainage ditches also belong to the surface drainage facilities of subgrades. So, what is a drainage ditch? It refers to diverting water from various sources within the subgrade areas, such as side ditches, interception channels, excavation pits, slopes, and accumulated water near the road foundation to designated places outside the bridge culvert or road foundation areas. In the diagram on the right, you can see that this is an embankment drainage ditch. The location of the drainage ditch is determined based on the needs and local topographic conditions, and should be no less than 3 to 4 meters away from the base of the subgrade slope. When setting up in a plane and needing to turn, it should be made into an arc shape, as smooth as possible, with a radius of no less than 10 to 20 meters. The continuous length of the drainage ditch generally does not exceed 500 meters. To ensure that the water in the drainage ditch flows smoothly and to prevent erosion due to high flow rates or siltation due to low flow rates, the longitudinal slope should be selected through hydrological and hydraulic calculations. Generally, a slope of 0.5 to 1% is acceptable, not less than 0.3% and not greater than 3%. As you can see in this diagram, the water in the drainage ditch marked as 1 needs to flow into another channel marked as 2, forming an acute angle intersection, not greater than 45 degrees. If possible, a circular curve with a radius r equal to 10b, b being the top width of the channel, can be used downstream to connect with other water channels. The cross-sectional shape of the drainage ditch can be trapezoidal or rectangular. On modern highways, trapezoidal shapes are generally used, and the size should be determined through hydrological and hydraulic calculations. For drainage ditches used at the outlets of side ditches, interception channels, and excavation pits, the width and depth of the channel should not be less than 0.5 meters, with the slope of the channel sides being 1 to 1 to 1 to 1.5. Stone or reinforced drainage ditches can adopt a rectangular cross-sectional shape. For clayey channels, including drainage ditches, when there is a risk of erosion and leakage, protective and anti-seepage measures must be taken. Now, let's take a look at the types of channel reinforcements. As you can see in the table, there are 3 major categories: simple, dry masonry, and mortar masonry. For different types of reinforcement, the thickness of the paving varies, such as for mortar rubble reinforcement, the thickness is 20 to 25 centimeters, generally suitable for areas with faster water flow in the ditch and higher requirements for seepage prevention. The type of reinforcement for the drainage ditch can be selected based on the relationship of the longitudinal slope of the channel bottom. From the table, we know that when the longitudinal slope gradients less than 1%, reinforcement is not required. When the longitudinal slope gradients greater than 3%, reinforcement is required, and the type of reinforcement can be selected from the 3 major categories we just learned. Choosing the appropriate type of reinforcement is key to preventing diseases in drainage facilities. So when you participate in the construction of drainage ditches in the future, you should uphold a spirit of dedication to your work. Remember every standard requirement, and ensure the subgrade is sufficiently stable. Next, we will learn about hydraulic drops. Hydraulic drops are set up in steep slopes or deep channels, where the bottom of the channel forms steps, and the water flows down in a waterfall-like manner. They are used to reduce the speed of the water flow over a short distance, dissipate the energy of the water flow, and thereby prevent erosion. There are 2 types of hydraulic drops: single-stage and multi-stage. First, let's look at single-stage hydraulic drops. They are suitable for connecting channels where the water level difference is relatively large and energy dissipation or change in water flow direction is needed. As seen in the left diagram, the water from the side ditch marked as 1 enters the single-stage hydraulic drops set before the culvert marked as 4, which is the hydraulic drop well marked as 3 in the diagram. When the steep slope is long, multi-stage hydraulic drops can be used to slow down the water flow and dissipate energy. In this case, the height of each step should not be less than 0.5 meters. The length of each step should be equal, and the steps should form a slope of 2% from the inside out. In this lesson, we have learned about drainage ditches and hydraulic drops, which are important components of the surface drainage facilities of subgrades. And surface drainage facilities are an indispensable part of subgrade engineering construction. I hope this lesson has answered some of your questions about drainage ditches and hydraulic drops. Thank you.